measure the flow through it because I jump around on a bunch of topics. So I was trying to put together some topics, and I thought, well, hey, I've worked on some really cool things. And I said, but some of these are like really cool, so they're awesome, But I had to make my own word up, awesomer. So they're more awesome than awesome. So that's kind of how I started out. So it's going to jump around a little bit. I've got a lot of videos, so I'm going to kind of crank into it. But I'm going to cover all the cool things that I think are cool that I've played with. So the first big one is space station out there. So everybody know what space station is. So what I'm going to do is one of our star nights, I'm going to keep watching for it, and if we see it come over, I'll try and get the word out around it. Come look for it. Deck 11 all the way forward. So it's almost, well, it's the size of a football field. I'll show you that in a second, but it's 1 million pounds that they've put up there. That's like 240-ish cars that they've put on space. And they put it up there like one piece at a time. And it's also moving at 18,000 miles an hour. If you kind of broke it down into how much space it has, it's like a 2,000 square foot house, but it really isn't, because that's all the equipment in there. And there's equipment on all 4 sides. So if you really look at the floor space in there, there's no floor. It's probably about 800 or 900 square feet, but it's a house you can fly through. So, you can just fly through it. So we'll show you that in a second. So this is what it looks like. These are all the nodes. So this is where the people live. Right in here, that's where they work. This is Soyuz capsule up there, coming up there to bring them supplies or people. And these are all the solar cells. And if you see it through the sky, those will turn, so it'll actually change its orientation and its brightness. So that's what it looks like kind of laying out on a football field. So it is easy to see when it flies over. This shows how it was all put together. Each piece, the truss here, the solar panels. It was made by like 4 different countries: Japan, Europe, Russia, China, not China. We left China out because they were playing by different rules. And so they have their own. Oh, and we when we were doing processing in the SSPF, the engineers decided that they wanted to name the modules themselves. And so they named them after the Teenage Mutant Ninja Turtles. And this one is Leonardo, I think. It doesn't say that, but it is. So do anybody want to go in? Take a look around.
As this setup is, it's a vast improvement on older space stations' orbital facilities, using an array of handrails which are situated at intervals on every servant-driven vacuum hose. This fan sucks any and all liquids away, whisking just to generate fresh oxygen and make the next batch of drinking water. Necessitate 4 hours just to suit up and be for jobs as apparently mundane as changing batteries on the exterior of the station. While the days of the week make even less sense than the difference between night and day.
So I would love to I'm just going to have to make a whole pitch on this, because it is, the scenery that they show on some of these videos, and that's kind of chopped because I was trying to just give you a little piece of everything all the way through. Does anybody know what this is?
Toilet.
I'm not giving away. That's too easy. Is it any bigger or smaller than the one you have? So you quit complaining about the one in your room. So there's a couple of things that are interesting about this toilet. The yellow nozzle there, everybody gets their own personal yellow nozzle. And you're supposed to switch the bag, the collection bag, every time, so the new person. So we don't have to do that on the ship, do we? So what's this? It's water. Okay, quick. Where'd the water come from? Urine. They reprocess it. They drink their own pee. It's not pee when they drink it. Come on, we're scientists. We can turn water, we can turn gold into lead to gold. We can do that. So this is kind of a show of things I'm going to poke into, but there's something called the cupola. And does anyone know what a cupola is? What's a cupola? I'll give you one. Oh, keep going. Okay, that's close enough. I'll give you that. That's close enough. So one of the things that happened was there were very few windows on the space station, very, very claustrophobic. So they made this thing called cupola. I've actually been on station and stood behind the cupola. No one's going to challenge that. It was in the high bay before it went up. So I didn't actually go in it on orbit, but I've been in a lot of the spacecraft before orbit. So this is what it looks like from the outside. It's got little things that come over and cover the windows, which is a pretty good reason to do. There's a good reason for that. These are the Russian modules, Soyuz, that comes up. So sometimes they'll have supplies in it, and then they'll take all the supplies out, fill it with all their garbage, which would be the stuff that came out of the yellow thing earlier, except for the water. And then we've got another one up there. So they always have one up there that if something happens, they can jump in and go home. And this is a little bit of why Butch and they're stuck. Excuse me? Oh, sorry. I just won't use it anymore. How's that? So, so that's why Sonny and Butch are on the space station. They're not coming home because there is one there. But if they come home, they won't have another one there for anybody else to come home. So they have to wait for another one to come up, switch places. One goes home and one sets up. So they're supposed to come down on the 19th. So that's where I have stood looking out that. And that is a dent in the window from a micrometeor impact. So it does happen. All right, so because we kind of left the Chinese out of this, they came up with their own. Tongjung? How do you pronounce that? Somebody for me. Tingjing. What is it? Tianjung. All right, very good. I'll give you a sticker for that because it's not quite a full answer there. I was getting close. So theirs is a little smaller than ours. It's their third generation one. They've had two other versions. This one hasn't been up very long. Sneakily enough, their modules look a lot like the Russians, don't they? Wonder where they got their design from. So this is their inside theirs, and if you'll notice, it looks a lot cleaner than ours. We have instruments on all our full wires. They do too. But even in space, even though there's no up and down, you don't really like to talk to someone upside down, so they actually kind of establish their own up and down just for communication purposes, because it's awkward to talk to somebody upside down. I don't know why, but we could try it if you want. So. So one of the things you saw him doing was cleaning. You exhale a lot of water, and if you don't clean constantly, it turns mold. And the Mir space station over here on the right was actually green on the inside from mold. And you don't want to do that either because in space there tends to be a very quick life cycle for that stuff, and so it starts mutating into things that like aliens. It can turn into really bad bacteria that is not great for your sinuses. Okay, so let's see. Another cool thing is just a shuttle in general, what it is. So just to talk about it, just to touch. When it's sitting on the launch pad and they light the three engines on the orbiter part of it, the plane part, those aren't on center. So the whole thing tips over about 6 feet and then comes back. It's called a twang. I'll show you a better representation of that later. But once it goes back straight, and the astronauts feel it kicking over, it's 6 feet, and they feel it kicking over. When it comes back straight, they light the solids. But each of the engines for the RS-25 engines have about 1 million pounds of thrust. There's 3 of those. The SRBs, I think, is 3.3 million pounds of thrust each. Huge difference. So when they light the SRBs, it's going. There's no doubt about that. That's all. And the astronauts tell you there's quite a kick, and it's very, very loud. They said when they're going up, you can listen to the boosters, and then they fall off, and it just gets completely quiet almost. It's probably because they're deaf by then from listening to the solids. So I guess we'll go for a ride. These tracking cameras are incredible. I think on one of the pictures I'll show you what they look. They're World War II gun mounts. I said that the other day, and the guys are cranking them and zooming in, but they're incredible cameras. And you on Challenger, you saw the film that they caught for the foam coming off, but they've I mean, you know what technology's done in the last 15 years. It's gone nuts. So cameras have drastically improved. The sparks. What are the sparks? Anybody know what the sparks are? No. Thank you for playing. Come on, there's a picture on it. Well, I'm going to keep this. The engine nozzle, to keep it from burning it up, they run hydrogen or oxygen through the nozzle itself because it's really cold, and that kind of comes out the bottom. Well, they don't want that igniting, so they throw these sparks out there to make sure if there's anything around that could catch on fire, that it burns very quickly before they light the engines. Otherwise, you could have a big day. Very bad day. I haven't seen you for a while. Where have you been? No problem. This is the hold-down bolts on the SRB. They're about that big. I actually made one out of wood just so I could see what it looked like, and I was going to show it to you, but it's in Florida because it's a long way to carry a bolt. But they break in half, and there's 8 of them that hold the whole thing down. So when they light the solids, if that didn't break, it's going to go anyway. It's going to rip it right off. So this is a SpaceX. They tried to launch one this morning, and they got scrubbed out. I think it's number 8, and they were going to try and catch it too for the 3rd time. So it has 33 engines. Each one of those engines, I'll show you in a minute, is 500,000 pounds of thrust compared to the same, very similar to the RS-25 shuttle engine that they use. It picks up about 150 tons, which is huge. That's the heaviest lift rocket we have that's out there. Burns all that fuel in about 3 minutes, 400 feet tall. So let's watch for a ride. I told you there's a lot of videos. It literally has to burn fuel to gain acceleration. It's so heavy. Seen the Super Heavy go. I keep wanting to go to Texas to go see it. They're going to start launching in Florida soon, but it literally shakes your clothes when some of these big rockets go off. So Elon decided why throw a rocket away? So he said, let's go catch one. First part of this is sped up. Watch this.
On the left hand. We're now down to 3 Raptor engines. We can see those chopsticks now.
So his team is probably the oldest guy on his team is 30. So that's why they're all going nuts. They come up with some pretty weird ideas. That's why his first Tesla's now in space. But a couple of things that are interesting about it, they don't have a heat shield. So the exhaust, what they do is they just literally start a fire in front of the heat and push it back with the engine thrust. So that the engines are the heat shield. A friend of mine has a PhD for a school nearby, and he said, hey, NASA put out a request for proposal on how to do this, and he said, why are you doing that? SpaceX is already doing it. So, what else? Oh, you saw fire coming out of the side of it? There's a quick disconnect on the side where they fueled it, and it was leaking, and so that obviously caught on fire, but it really didn't affect the performance. There's a couple of aero surfaces on the side. It actually flies back. It doesn't look like it flies back, but it does. So this is and it's the size of a football field. It's as long as a football field. And this is the upper stage, the Starship coming in. I took away the audio because it didn't make sense. So it flies halfway around the world and it lands right by the camera. So they landed it right where they wanted to land it. Now, they stop the film usually, but when it falls over, it usually blows up. But they go out there and there's something floating around and they try and bring whatever they can back. Elon's term is that we learn by our mistakes. So we want to work fast enough where we're making a few mistakes, but we can learn from them and move forward, especially when we're not doing manned stuff right now. So this is the two engines I was talking about, just drastic difference in the two engines. You can see how complex one is and the other one's not. The price of them, I think the latest contract order for the RS-25 was $100 million a piece. He's trying to get his down to around 200,000 a piece. And he reuses them. So, and the complexity, he's setting up more of an assembly line for him. Now we can go in, no, we're not going to do that. Does anybody want to look at the engine design? No. There's like 3 of us. Yeah, the one they caught. They call the big thing Mechazilla. They caught the first stage, the super heavy booster. They're going to use it again. So, how did they steer it? It has grid fins on the top. There's 4 of them, and they turn these things. And if you looked on the side, there's actually wings. There's little fins. No, it steers itself. It flies itself back in that cradle. They're smarter people than me. That's really easy, by the way.
Write that down, man.
Yeah, it flies itself back in. So this is the result of that. If you look at like the shuttle program and the Saturn V, these are like the cost per kilogram, and Starship's coming down here relatively low. So think about everything you send up there. Like they don't have a washing machine on space station, so they throw their clothes away every week and get new ones. What's an outfit cost on the space station? Right now it's about $12,000 a kilogram just for a T-shirt. So this is inside their processing bay out at SpaceX pad. So they integrate horizontally flat. So the middle one here is the Falcon Heavy. So it's really 3 Falcons all glued together. You can see the landing legs on there. I'm not shooting anybody. These are the landing legs right here. These things pop down, they're right there. And this is a regular Falcon 9 over here. So let's watch one fly.
The engines.
Aquarius booster separation confirmed.
1 and 2.
Stage 1 camera.
Stage 1 landing leg deployed.
What an amazing view.
So in this case, they caught all 3 pieces of the super heavy, but if they have a really heavy payload, they'll take off all the landing legs and they'll just burn the whole vehicle. But some of these they've flown 25 times. So that's what's getting amazing. He said it costs about, I'm probably repeating myself, but it costs about as much to refuel it as a 747. So reasonably priced for putting up a $400 or $500 million satellite. Now this is his Dragon capsule, and then it's getting ready to dock with the space station. I'm gonna have to speed up just a little bit. The puffs are the thrusters that are called Reaction Control System, RACS, RCS. So there's a target on the side that they're going to grab it with a Canadian arm there. Then you pull it in and set it down on the space station. You definitely want a soft dock to the space station. Anything going boom, it doesn't boom, there's no sound. This is actually, I saw this over my house. It's the re-entry of the Dragon capsule. I was thinking it was going to be like a small thing. You can't miss it. It's stretched across the tops of like 3 houses. It was so long, and there's people in the end of that. There's about four people right in the end, and it landed off the coast of Jacksonville, and they brought it back into Port Canaveral. So this is the Falcon 9 in Port Canaveral that you can see when it comes in. It comes in on that barge. Of course, I Still Love You, is that what it's called? And this is, we were on a ship last year, and I looked and I saw the launch, and this is what happened. You can actually see it leave Port Canaveral from Fort Lauderdale. Flew right over the ship. Flew right over the ship. I kind of knew it was going to do that. So this is a new rocket program I'm sure is going to give Elon Musk a run for his money. So I did this for our church, the kids, because it only costs it doesn't cost anything to make a 2-liter bottle fly. But I didn't get any of the payloads back. I don't know what happened to all those. So this is what we see from my house. This house here is mine. So this is from the backyard, this is from the front yard, and this is from down the street. And it happens 2 or 3 times a week, as much as 3 times. And you can hear it. Something watching. I don't know who's paying my electric bill. I had one from the river, but I was running out of time, so I had to cut that one. It's a blue moon. It lights up the whole sky. So we're going to jump to, I realized that NASA had an A in it for aeronautics, so I decided that I could actually talk about planes. For this, it's I think it's monomethyl hydrazine kind of thing. It's a hypergol, but it's also got oxygen. I know it was a very I can't remember it's not monomethyl hydrazine, something like that, but it's the same kind of fuel that they were using in the Kursk, the Russian submarine that had the torpedo blow up. So we're going to get there in another one. I'm going to show you one blow up because of that as well. But it's a pretty caustic fuel. It's hard on all the valves and everything, and it's kind of dangerous to use. But at this point, this thing's pushing the state of the art. So we're going to go into this because I've got a real good shot by Neil Armstrong in here, and I wanted to go into that. So I'm going to kick on through here. This is it in the Smithsonian with a model of the limb, and Apollo 11 in Colombia is down here, right around here somewhere. But this is the one that Neil Armstrong flew in. There's 3 of them. There's 2 of them. One crashed, and I'll get into that in another video. But every time they break, they fix it. So it drops from a B-52. They take it up about 40,000 feet. You can see the white belly. That's liquid oxygen. Neil Armstrong. A lot of records set for this that still stand to this day. Mach 6.7 going up. And that 67 miles, that gets most people astronaut wings, which is going to come up in a minute.
1962, that would prove to be the most memorable. Armstrong's assignment that day was to test the X-15's new control system.
Ready to launch now. Good night.
When he separated from the wing of a B-52, Armstrong fired his engines. He accelerated at more than 5 times the speed of sound, reaching altitudes exceeding 200,000 feet. His control was good. But when he burned up all his fuel and was beginning his free-fall descent, the nose of his X-15 was still pointing up, which caused it to bounce off the atmosphere, throwing Armstrong nearly 50 miles off his intended course of Edwards Air Force Base in Southern California. The dry lake bed at Edwards was Armstrong's only option for a safe landing. Not only did he not have any power to go elsewhere, but because the X-15 used metal skids for landing gear, the dry mud of the lake bed was essential. Armstrong was falling back to Earth fast, and for several thousand feet, he couldn't maneuver the aircraft because of the thin atmosphere. Finally, he fell far enough that he could turn the X-15 and point it back towards Edwards Air Force Base, where he made an eventual safe landing. Armstrong's flight lasted 12.5 minutes and covered a distance of 350 miles, making it the longest X-15 flight, both in time and distance. Of course, none of that was by design, but it nonetheless added to the lore of the courageous pilot, who a few years later would become the first person to walk on the moon.
So this is what I wanted to play for. This is one of 4 times where he probably shouldn't have survived. This plane has almost no aero surfaces for turning. What's the question?
What was the landing speed of it?
Over 200 miles an hour. So it was very fast. And that's going to come up in my 1, 2, 3, oops, 3, 2, 1, oops one, where they kind of break it in half a couple of times. And, but they always put it back together. But he was known for being calm and cool. They do have something called the RCS thing that I was talking about earlier, the reaction control system, that they can steer outside the atmosphere, but it wasn't cutting it. And this is also where they learned that they need to come in at a certain angle back from the moon. Too high, you bounce off. This is what he's doing right now. Too steep, and you come in ballistic like a bullet coming down. So they have to come in at the right angle. They can actually steer the capsule by spinning it and make it go up and down. They can actually fly the space capsule. So this was a big deal. And this was one of 3 times. I think I've talked to you about the limb where he ejected from that, and then landing on the moon was another one. He basically they do lose one of their planes and their pilots doing this later. So this was kind of a bummer. You know, you got these Air Force pilots, and they defined space at like 50 miles. Is that what it says? 50 miles, somewhere around there. But the FAA, the commercial side of it, was 62, and so they immediately gave the astronauts that were part of the military, they gave them their astronaut wings for achieving that. And they did not give the astronaut wings to the crew of the civilian pilots, which Neil Armstrong was a part of. So if he'd have been there, he wouldn't have got his astronaut wings. So 35 years later, Neil shows up and I guess pushed for them to get their wings. A little late, don't you think? So 35 years. Thanks a lot, but thanks, you know. So Cassini, anybody heard of that spacecraft? Pretty cool. So we're going to talk about that a little bit because I helped launch this one, and I'm actually in the video. So.
Yeah, NASA launch manager from Kennedy Space Center, the launch vehicle manager from Lewis Research Center, and also our 3, 2, 1, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn. Pitch program is in, roll program is in.
So Titan. Launch vehicle.
We have cleared the tower and been supplying data.
Yeah, so my job in that room was to make sure the room was configured and working for everybody. So I have to sit in there if they need help with anything. And these are all like the big wigs, mission directors, like all the launch director, the spacecraft director. So and that's the launch director right there. NASA people are back here. So this is Cassini. It has another part to it. It's called Huygens probe, and they're going to land that. They're going to kick it off and land on Titan. So these are some of the, I have to show you what it did. So these are some of the pictures that it took. It found a couple of moons, took like 50,000 photographs. These are jets of gas. This is actually video of the landing of Huygens probe on Titan. I didn't run you the whole thing because I think it finds aliens at the end. No, it doesn't. This is about 20 minutes worth of video. But it doesn't look a whole lot different than things we're seeing on Mars, which is later in the pitch. So like I said, they took from 500,000 photos. The cost of it was $3 billion. I think I was sitting there with the mission director spacecraft director, and we were calculating it was 50 times the price of gold by weight. So we're going to go for one more ride. It's used up all its fuel. The government spent all the money they're going to spend on it, and they're going to do something with it.
In space, NASA's Cassini spacecraft is running out of fuel. The spacecraft carried a passenger, the European Huygens probe, the first human-made object to land on a world in the distant outer solar system. On the final orbit, Cassini will plunge into Saturn, fighting to keep its antenna pointed at Earth as it transmits its farewell. In the skies of Saturn, the journey ends, as Cassini becomes part of the planet itself.
So it has no heat. I didn't take those pictures, by the way. It has no heat shield, so that was not. There's no way. The atmosphere is very, very dense. It was gone very, very quickly. That is the rings of Saturn. And it's interesting because in order to orbit it, they can't really fly through the rings, because even though it looks very dense, it isn't, but after flying through it a bunch of times, you're going to hit something. So they actually had to fly in the gap between the planet. So one of their orbit was outside the rings, another one was inside the rings. That's how they orbited, so they didn't hit anything in the rings. But then they could take pictures of the rings when they got really close. So it was elliptical orbit. Dust, rock, things like that, small bits of, it's actually very thin too. I'm going to get this wrong, but like inches thick. It's not like miles thick like you might think. It's very thin. I'm going to have to look at that, make sure I know what that is next time. So this is one where we intentionally tried to land on a planet. It wasn't a planet, it was an asteroid, Osiris-Rex. So we decided, hey, we're going to fly out there and we're going to land a probe, take some samples, bring them back to Earth, see what the asteroid looks like. Now, we'd already done this before by accident. So there was another asteroid that we had flown, and we had had a spacecraft orbiting it. They have a very low gravity. You could take a baseball and throw it into orbit, very low gravity field. And so, again, they're flying this little spacecraft around, and they get to the end of the mission, okay, shut it off. And some of the guys said, well, why don't we just try and land it? I said, well, it wasn't designed to land. It doesn't have any legs or anything on it. Well, what does it matter? We're just going to turn it off. And so they actually tried to land it. It landed, and it bounced on the ground. They're still getting data. I'm like, hey, we landed it. Now what do you want to do? Well, let's try it again. So I think they tried it a couple of times, landing it. So they actually are probably one of the first people to get credit for landing on another asteroid. But this one, this is what it looks like here, all packed up, getting ready to go. Everybody's in their green room garment. Everything's ready to go. This is what it looks like. I did not take that picture either. So it went up on an Atlas V. This is, part of this is simulation, part of this is real. This is real. So, remember what anybody here for the Apollo 11 one?
Yep.
I said that Neil Armstrong was basically the guinea pig or canary. He was running out. They didn't know how the soil was going to interact with him walk around. This probe by accident went 3 foot deep into the soil and basically got stuck. And they had to fire the thrusters really hard to get it out. Then when they got it out, they had so much dust and debris in the collector that it wouldn't close, so they had to open and close it a few times to get it down to something where it could close so they could get it back to Earth. But that's, they didn't know if they were going to run into something like that where it was so loosely packed that you step on it like snow and you fall down in 3 feet. That would have been really bad. So this is, it came back by the Earth and it threw out a little lander, and there's the parachute, and it landed in Salt Lake City in the desert out there. And then they put it in a plexiglass thing because they didn't want any little aliens jumping out, if there might be aliens in there, or any aliens getting in, and you can see the kind of things that they're pulling out. But it's basically pretty much all the same kind of material we're still seeing. So there's been a lot of talk about how much certain asteroids might be, because they're made out of like titanium and things like that. But realizing that to get an asteroid and bring it back to Earth is going to be a big deal. We're already worried about 2024, which is going to come back by around in 2029, and we're worried it's going to hit the Earth. And it's a pretty good size, so no one's in any hurry to encourage any asteroids to come hit us, which is what you would be doing if you went and mined them. So now we're going to go to Mars. Is that okay with everybody? Somewhere the photo disappeared. Oh well, maybe it's the next one. So the guys so we have a family of robots running around on Mars. So they're Sojourner, Spirit, Opportunity, Curiosity, Perseverance, and a little helicopter, Ingenuity. The JPL guys that made this made the little metal wheels, and they wrote JPL on them so that they would thrum, and write JPL everywhere it went. And the public said, we can't do that, we can't do that. So they did it anyway, they did it in Braille. Never tell an engineer he can't do something. So, and their justification was there, if the wheel starts to slide, then the Braille will be smeared, so we'll let that one go. So this is the family out there, so you can kind of see. So there's two of these, and two of these, and one of these, and this is their creator. I don't know who that is. It's just for size comparison. Oh, they're running, they don't run on solar panels, they run on RTGs, radioisotope thermal generate nuclear powered batteries is what they are. So let's go land. Let's see how they land this thing.
Downrange visual is separated from inspired the ground. We are in our flight. 5 meters altitude. We found a nice flat place. Standing by for sky. Sky green is running. Take a lot, you remain strong. Just good. Touchdown.
Okay. Why so complicated?
What's the question?
Why so complicated? Somebody at least raise your hand. Okay, this man back there in the blue gets this. Can somebody pass that way? Wow, he not even guessed. He guessed right. Did you guess? So so I'll repeat it. So the question is, why was it so complicated? Well, if they take a spacecraft and land it, it's going to blow a hole in the ground because Mars is much bigger than the moon. So it's going to blow a big hole in the ground. All that debris is going to come back up and hit. The other ones they landed by putting in a big airbag and bouncing the airbag down, and then the airbag deflated and they drove out. So they do the sky hook kind of thing to drop it down so the thrusters are way up in the air and it gets down, and as soon as it touches, the cable's cut loose and it flies off. Oh, and it lands over here. So that's the heat shield. So what do you do when you go to the Mars? You go look at something that came from Earth. That's got to be funny. How much money did that cost? Excuse me?
How did you get the photos? Yeah, that's right.
Excuse me?
The photos.
The video.
I made that video. There's no video of it coming down like that. There is internal video on. The question is, how did we get this video here of this coming in? There's no video of that. It's animated. I wasn't going to tell you about it. But the point being that there is some video of part of it filming it coming down. I think I've got a picture of that in here in a minute. But that you can't. You have to have something else. Now the Chinese did something pretty neat. They had a lander, and the first thing they did is drive out and drop a camera and then drive away from so they could take pictures of themselves. So we do it a different way. We have a selfie. So these are actual pictures of Mars. Looks like rocks to me. Yeah. It's hard to tell how big they are, but this is kind of a viewpoint from you basically standing there looking. So they're about what you would imagine it to be. I don't know what that is. So this is real shots, and they're drilling a hole in a rock to try and figure out what the rock is made out of. More rock. So I wanted to tell you how they get these pictures. This is what the camera takes a picture of right here. That's it. And then they take a ton of these and they digitally put them all back together and get a very, very high resolution image. This is a selfie. How does he taken this? He basically, they have film where they hold something way out and they take pictures all the way around, and then they cut the arm out. They digitally take it out. And so it looks like it's being taken by somebody else. That's just a bigger shot of that. You can see where it's been driving around. So this is, holes, laser. This on the right, on the left over here, is it actually coming down on the cables? So that's the cables before it releases. That's the helicopter. So this is what it sounds like on Mars.
Of a helicopter flying on Mars.
I don't know that I could hear that last one, but the zapping, they're shooting a laser to kind of clean it off so they can take a better measurement of it. So the wheels clunking on the rocks, they're metal, they make noise. The atmosphere is like 1/100th of what it is on Earth. They saw all these little dust storms that you saw in the background, and they were really worried about them until they actually hit the rover and cleaned the solar panels off. So they really like those. Because they get dirt stacked up on top of them, there's no way to get it off. So they were basically banking on little windstorms to take them off. So in the movie The Martian, where he gets everything, did anybody see the movie The Martian? Yeah. Where he gets blown and left behind. So this is, you gotta give me more than that. This is a full-blown picture. Come on, what's his name? Who said Lake over here? All right, we'll pass this back over there to him. If you won and I gave it to the wrong person, just see me afterwards and I'll laugh. Yes? I don't know the answer to that. It has a lot of CO2, nitrogen, not oxygen, so that's what we know for sure. But it goes from being like really freezing cold, or the heat from the planet is here to like really cold here. I mean, a 6-foot difference is huge in the atmosphere for that, but there is enough to aero brake coming in. There's enough to slow the spacecraft down, and that's what it was doing when you saw it flying in. It's got a big heat shield, and lets the atmosphere slow it down. Because if they don't use that, then they got to use gas, and gas's weight makes it bigger. They don't want to do that. So, well, let's find out. Let's wait. I'll do that in my next cruise with you, okay? Because I don't know yet. That's what he's building that Starship Heavy for. So this is Laika the dog. That's the picture we have, and this is what AI did to it.
Exploration. Although she did not survive the mission,
generated.
Laika's journey paved the way for future human space travel.
I'm going to stop it right there. What does HAM stand for? Come on. I don't know. I know it's written up there in a minute, and I'll know. Hollow Man. Okay, let's find out. I'll give myself this. Oh, wrong way.
In space exploration.
Doing good.
Although she did not survive the mission, Laika's journey paved the way for future human space travel.
Come on, here it is. What does HAM stand for? What was it? Hollow Man,
Mission.
Aerospace,
Mission.
Medicine. All right, pass this over to the man in the white shirt. Not that these little pictures are worth too much. He did basically spend out his days in luxury in a zoo. I had talked to a friend of mine. He heard a story that after he got back, they went and put him in a simulator to do some more testing. He bit him. He's like, I'm not going back in that thing again. Oh, and I'll go ahead and say it. We talk about HAM, how we so graciously put him up, and Laika didn't live because it's a dog and it overheated in space, and they really didn't try too hard to bring him home. we did the same stuff. The ham was not the first animal we put in space, so the others did not fare very well. So all this has to lead to something, right? We can't just have everything go towards, and I'm not saying these are a direct correlation to the space program, but it has spurred technology to give us some other things. Has anybody ever seen one of these videos where the people put these cochlear implants in? They've been deaf. I thought I saw somebody actually walking around with one.
There's a couple.
Who, is he in here? Tell him he missed a picture, because I was going to give him one. Just to go from never being able to hear, and they're doing a little bit with blind sight too. We're now going to have some, like robots to help us. Now that's not that awesome, is it? Well, if it looks like Scarlett Johansson, it might be a little awesome. And heart valves. I mean, pacemakers. I won't ask that question in the audience. Moo, does anybody know what that means? Come on. Why would I write moo on a heart valve? What is it? Okay, who said cow here? Okay, I got to take my entertainment. Now this is a valve kind of that my father had when he was 57. It's basically a ping pong ball bouncing around in there. This is another one that looks like this moo one over here. It's made out of parts of a cow. It's not a cow valve. It's the sac around it. I figured that mine has opened almost 297 million times because I have one. So, and by the way, don't do that for something that's not fun, particularly if you've already done it. But that's what mine looks like. And you can see it looks just like this, just like it, twins. And then there's self-driving cars, which is amazing when you can go to sleep while doing it. So, okay, that's not recommended in the manual. I think it doesn't say do that. So I don't know if this is true or not, but it's something to think about. There's a big crater in Arizona, and there's a big dent down here, and boom. I don't know. This is a religious site, so I'm not trying to make fun of the religious site. Well, that's what I have. I'm going to be here all week, locked on the ship with you. I've got 4 more to do, I think. Is that right? So 4 more to do. You'll be tortured through. This one is a little different than the other ones. I didn't really have a solid story all the way through, but they're just some cool things I wanted to show you. And I will now try to answer a few questions. But while I'm doing that, I'm going to play you something else to look at. There's no audio, but you can watch it and then ask me questions. And I have stickers for the questions. Oh, that's cheating. State the questions. Stickers. That is a really good question. In fact, you know what? I think that's such a good question that you have to give that picture to somebody else now. You're going to upgrade. Let's make a deal. Door number 1 or door number 2? I don't know what door this is. So the question is, what's the status of the solar panels on space station? It's been up there for quite a long time. They're in bad shape. They're thinking space station is probably going to be out of service in the next 10 years, probably less. Another sticker. This is an actual sticker. These are satellites that fly over our boat at night. Last night we saw 30, and the other night we saw. So what's the plan to deal with all the space junk that's up there? We have no plan. There is a plan to keep from putting junk, but they're really not restricting anybody to put satellites. They don't let little bolts and things fly around because they end up hitting the windows and putting dents in windows and things like that, which is really bad on makes your insurance go way up. Hailstones and stuff like that, that's a joke. So when I worked for a spooky agency, we tracked things that I could tell about, and at that time we were tracking more than 18,000 objects that were basketball size or bigger. And that was a long time ago. Did I give you, you've got plenty of stickers. There's no limit. So the X-15, it's an X program, experimental. It starts anyway. It was strictly for research purposes. They wanted to find out what it takes to go that fast. And there's always this, is anybody from Russian here? Sorry. Beat the Russians kind of thing. But it was strictly an experimental program to learn to go into space. And there were 2 thoughts, that they could fly up just like a plane and just keep going, and they did, but they really never achieved orbital velocity out of it. That's 18,000 miles an hour as opposed to what they were flying, which is about 4,000 miles an hour. Yes. Yes. So where I live in the middle of a swamp. The question is there an environmental impact for these rockets and stuff taking off? There is, and they have there's a season of some bird in California that we can't launch during that season while they're doing their mating thing because it disturbs them. So there is a lot of that going on. We do watch. We have a great partnership with the alligators and stuff, and they do not mind us launching. I've asked a few of them personally. Two more questions after this.
Okay, on Mars, how far, what's the distance that sound carries?
The atmosphere is 1/100th of ours, so it is very hard probably to hear. You could hear the wind on Mars, but it's nothing like here. The denser the atmosphere, the easier sound transmits. So that is an issue as well on Mars for how sound is transmitted. So, but it does go through. You have to have something. If you're in space, did anybody see Aliens? In space, nobody can hear you scream. That was a spooky movie. There's one more after this.
The angle you have to, for a vehicle to enter the atmosphere, how much of a degree of air?
So he's asking about the Neil Armstrong when he came in and bounced off the atmosphere, what the angle is. It's different depending on the vehicle. So it comes in at a certain angle where it can come in fine, or it can bounce off, or it can go in ballistic. It's dependent on the speed of the vehicle. So that's why our vehicles for our capsules were like capsule shaped, so they could hit that a lot easier in flying. But a plane, it was actually going towards the atmosphere, so much easier, like a skipping stone across a lake. Much easier to skip that than to try and throw it up in the air. It just goes boom. So last one right here, and then I've got to switch out for the next guy, John, my cohort. No, I was playing around. The question was I suggesting that Ayers rock out in Australia could be like a meteor? I have no clue. I'm not a geologist. It was kind of a joke, but again, I'm an engineer and they don't translate. Well, thank you very much. John.